Welcome to Learning by Watching, Breakthroughs in Robotics Research. In this episode, we explore the latest advances in the cs.RO robotics research category, featuring 17 cutting-edge papers published on November 26, 2025. We highlight how robots are now learning from everyday videos, with a special spotlight on the TraceGen system, a major leap in robot learning. Key trends include the integration of vision, language, simulation, and advanced control. AI Frontiers is your guide to the forefront of robotics innovation. Can a robot learn from videos filmed on your phone? This question, once the realm of science fiction, is now a reality. Today's robots can successfully mimic tasks after observing as few as 5 short cell phone clips. Imagine teaching a robot to fold laundry simply by recording the process with your phone. The gap between human and robot learning is shrinking rapidly. What was once impossible is now the subject of everyday research. The future where home robots learn like humans is closer than ever. Why does robotics research matter now? Robotics is a field that unites artificial intelligence, computer vision, language understanding, and advanced control systems. Unlike controlled laboratory settings, real-world robots must operate in chaotic and unpredictable environments. The 17 papers discussed today provide a window into the ongoing evolution of the field. The goal is to make these breakthroughs accessible and actionable, allowing listeners to see how robots learn, adapt, and collaborate across diverse settings. Robotics can be seen as a symphony of disciplines, with the cs.RO category representing a vibrant crossroads of scientific expertise. The field blends mechanical engineering, electrical hardware, artificial intelligence, and human-computer interaction. Robots are not just mechanical bodies. They require minds equipped with perception, reasoning, and planning. Think of robots as orchestras, where vision, movement, and planning must work in harmony. The cs.RO papers serve as the sheet music for the next generation of robots, addressing challenges beyond tidy labs and focusing on real-world success among people. Rapid evolution and collaboration are driving progress in this dynamic field. The first major theme is foundation models, which function as universal chefs in robotics. Foundation models are large, pre-trained systems capable of adapting to a wide range of tasks, robots, and environments. TraceGen, developed by Lee and colleagues, serves as a universal translator for movement, enabling robots to learn from both human and robot demonstrations, regardless of the camera angle or recording device. This approach is analogous to a chef who can prepare any recipe, not just familiar ones. Foundation models like TraceGen pave the way for flexible and inclusive robot learning. Another transformative theme in robotics is the integration of vision, language, and action, known as vision-language-action, or VLA models. These models enable robots to blend visual perception with language understanding and physical manipulation. Notable examples include the E0 system by Jean and colleagues and Vacuum VLA, both of which unite perception, language processing, and manipulation. As a result, robots can follow complex instructions, not just simple commands. This is akin to giving robots both eyes and ears, along with nimble hands, empowering them to operate more naturally in human environments. Robust perception is critical in robotics, especially in uncertain and dynamic real-world settings. The SLU method, developed by Shakewitz and collaborators, mathematically bounds uncertainty in object pose estimation, equipping robots with a form of confidence meter for cautious actions. Real-world environments are noisy and unpredictable, so explicit uncertainty quantification is essential for safety. Just as humans slow down when driving through fog, robots using SLU can act more cautiously when uncertain, paving the way for safer and more reliable autonomous systems operating in the wild. Recent breakthroughs in robotics are best illustrated through a series of mini-stories, each highlighting a key innovation from the November 26th papers. TraceGen by Lee et al. enables robots to learn from as few as 5 cell phone videos with no need for calibration. cs.RO, from Shakowitz et al., delivers precise and rigorous uncertainty bounds, with open-source code available for the research community. E0 by Jean et al. Introduces discrete diffusion for robot actions, producing smoother, hardware-aligned steps. Arova and colleagues demonstrated robust bimanual manipulation that transfers smoothly from simulation to real robots. Each of these advances directly addresses a real-world robotics challenge. The standout paper of the day is TraceGen. World modeling in 3D trace space enables learning from cross-embodiment videos, authored by Lee and colleagues. TraceGen allows robots to learn from any video, whether featuring a human or a robot, and from any camera angle. The system shifts focus from pixel-level information to the geometric trace space of demonstrations. The research team developed TraceForge, a software pipeline that converts diverse videos into consistent 3D traces. By pre-training on large trace datasets, TraceGen enables rapid adaptation to new tasks, overcoming the traditional bottleneck of requiring high data and high calibration learning. Inside TraceGen, the process begins by abstracting away visual details and concentrating on the geometry of movement. The system can adapt to a new robot or task using as few as 5 short demonstrations, which can simply be cell phone videos, even those made by humans. In empirical studies, TraceGen achieved an 80% success rate with 5 adaptation videos, and the 67.5% success rate when trained on videos from humans. This performance surpasses models that require more data or struggle to generalize across different robot embodiments. TraceGen's impact lies in its philosophy of democratizing robot learning. By focusing on the geometric essence of demonstrations, it makes advanced robot learning accessible to anyone with a smartphone. The system enables quick adaptation to new tasks, robots, and environments, and encourages community sharing, allowing robots to learn in a manner similar to humans by watching others. This approach sets a precedent for future research in generalization and collaboration, fostering an inclusive and flexible robotics ecosystem. Looking ahead, the future of robotics is shaped by the idea of evolution through imitation. Imagine robots learning not just from curated datasets, but from social media videos and from observing each other. This process is analogous to the way skills spread in evolution, by imitation rather than explicit programming. Advances in simulation platforms and the integration of richer sensory data, such as touch and sound, will further expand the possibilities. However, challenges remain in sim-to-real transfer and generalization across diverse tasks, robots, and environments. The path forward envisions collaborative and ever-adapting robot partners. In summary, robotics now stands at the edge of possibility. Robots are learning from real-world videos with minimal setup, and the convergence of vision, language, perception, and control is driving the development of new intelligent systems. The cs.RO research community, including Lee, Shakowitz, Zahn, Hurova, and colleagues, sets the pace for innovation. Listeners are encouraged to imagine teaching robots new skills, consider the impact on daily life and industry, and actively participate in shaping tomorrow's intelligent machines. The preparation of this presentation involved a collaboration between artificial intelligence, text-to-speech synthesis, and human expertise. Summaries were synthesized using GPT 4.1 for narrative clarity, while text-to-speech capabilities were provided by advanced models. Visual elements were generated using image tools from Google. Human experts reviewed the content for technical accuracy and coherence, though some oversights may remain. Listeners are advised to consult the provided references for detailed information on each cited paper. To stay connected with the latest developments in robotics and artificial intelligence, subscribe to AI Frontiers. The channel offers deep dives, expert insights, and timely updates on breakthroughs in the field. Listeners are invited to share their thoughts and questions, and to join the growing community exploring the frontiers of robotics and AI. Thank you for accompanying us on this journey.